Hi students, welcome to tutorial number 7. Today I want to look at a little bit closer at structural systems, and I wanted to look at what are your options and what are the type of impact that it has on aesthetic and technical detailing. So here we go. Let's get my page out. New page, new drawing. Okay, so after critiquing a lot of students, I noticed that a lot of students are doing quite complex forms, which is actually really good. And just some basics that has come up. A lot of students are doing, if they're doing and this is in plan, say they're doing a square or rectangular plan, the natural ability to hold up that building can often be on the corners, and sometimes you might need one in the middle. The problem with this is aesthetically and formally. So if you have a project that looks like that, what you're going to end up having, if you have concrete beams, columns, you're going to end up with a table. And that never really looks great. So if I had to put another box on top of here, it's really that's what you're looking at. The problem with this is, of course, that structure goes through. There's a number of problems with this system. Although this is the most efficient. We had another column over there. Looks terrible. The problem with that is a number of things. Number one, the aesthetic. So what I mean by the aesthetic is two things. You're going to end up making a box that looks like a box. So unless that's what you want, for whatever good reason, which you're going to have to defend, then I guess that's what you're going to end up with. But the problem with this, if you zoom in a bit, is always how you're going to build this thing. So this is the second problem. So one is the form, let's do is the aesthetic or the form. And by form, you can see that the shape ends up, your eye is drawn to the fact that it makes a box. Okay. Number two is the detail. Both the practicality of it and the aesthetic of that detail. So I'm going to zoom in here, take a square column, I'm going to draw the edge of a slab. Okay, what that means in elevation is that you're going to end up with something like this. You can only, from here, end up putting in, if you're going to put glass in, you're going to put glass in like that. It's going to be a square thing. But there are so many different other forms that you could do, or shapes, or kind of things that you could. But it's the most practical, but you're going to end up with that. What that means is that you're going to end up putting your glass right next to up to there. And it's really just aligning everything. Now, there are options with doing that, which I'll come back to now. But the third thing is the waterproofing of this. Is that you have to be careful that you have to waterproof all around that edge, silicone, all of that, because it's not really great connections. All of that you have to waterproof quite carefully. Okay. The fourth issue with this is the planning. So firstly, you're never going to get that whole view that we spoke about if you're sitting and working, because you've got that column in the middle. So you're going to have to rely on some kind of beam here. The other thing that I wanted to bring up, I'm going to delete all of this, is that your columns need to help you. If I've got a space like this and I've got a piece of glass coming out like that, and I've got another wall coming down like this, that glass obviously sits on an edge of a slab, which is what I'm drawing now. Let's just draw it with a bit lighter. Some line weights. Okay. What I've seen some students do is they put a column over here. Let's do that in red. And they put a column here. Now, we all know now that you can actually put structure inside of walls. So the trick here is to take your columns and place them in the walls. That does two things. Not only is it aesthetically more pleasing, but it also will be out the way now. You don't have to deal with this column being in the way. So you get that cleaner look. The technology of that, of course, is if you zoom in, you've got a concrete column, and your thinnest column you can work with is about a 230, which brings you to your brickwork. And the detail around that is when you build a column, what they do is they nail gun a series of hoop iron straps to that column so that the brickwork can sit inside of that, so that the lateral forces resist the brickwork from falling out, if this is your column. But they'll also put in a joint, a soft joint. So in plan, it would look like this. At a much bigger scale, just draw this. That's your concrete column. Put a 10mm soft joint in there. You've got your hoop iron strap coming through, and you have your brickwork. Let's make this nice and thick. That would be a typical real detail in real life. So that's the one scenario. Then delete all layers. The other thing is, if you're doing large structures like this, so you're doing a water tank or you're doing a big space, even if that space ends up being the toilet, you walk in, there's a basin, and there's a toilet over here, that can now become your structure if you made that out of concrete or this out of concrete. And if this was your floor, that means that you're supporting kind of this area and you're supporting this area, but you still need to support this area. Because of the distances. So if you're looking at about 6 to 8 meters, this point would be half of that, or that point would be half of that. So you're looking at about 4 meters to that side and 4 meters to that, which gives you about 8 meters, so that I can span with a beam that sits in underneath it. So I'm going to need to put a column somewhere along here. So what I will do is I'll place a column. I can either place it on the corner, but as I mentioned earlier, it's not always the more interesting thing to do, unless I do a column just on the inside of this space like that, and perhaps another column over there, something like that. So what I end up is a structure where I've got a toilet. It's made out of concrete. So on the one floor it's the toilet, on the next floor it's a storage room, the next floor it's a kitchen. Let's do that. And then I have a column that sits like this. Why would I put a column like that? Maybe because when I go up, and I go up there, perhaps I cut into it like that, and that's my entrance off a bridge that I just created. So I want that column and that column to line up with that corner. Then I have glass on that side or something like that. So that's a way of getting away from conventional structures. You can also, what are the other options? I've seen students doing circles or intersecting circles. So the options here are, you can either do a column that supports both of them on those two corners, but then you're going to have a column there and a column there, provided that your spacings are about 8 meters apart. And the alternative to that is you put a column in the middle. Now the dynamics around a column in the center means this thing, it wants to wobble. But because you're doing two, they're kind of supporting each other. And to prevent the puncturing through of a central support structure where all the forces are coming back to that column, what you can do in section, or in plan, in section, is you could put another radius around that. And instead of having a column that just does this and a puncture that comes through, you can drop cap that. So what that means is that instead of the support running all the way along, just with this yellow, all the way coming along here and then down, you're now shortcutting that the line of that structure flowing through. Even better, what you could do is you could start tapering the entire slab all the way back to this column. So it's like a little mushroom in a sense. In that case, you'll have to, if I zoom in, you'll have to end up having some kind of beam. If you have this drop cap story, and you end up with a return beam in the background, what that does is it allows for whatever brickwork or any kind of glazing on the side, it allows the forces to, for this beam to carry that weight and then carry that weight all the way through down around the beam and then through the slab. In this case, you can start looking at an alternative. You can even start looking at upstand beams. If you want to do. And why would you do an upstand beam and a downstand beam? Let's look at clearing this first. Clear all layers. Okay. Upstand beam versus downstand beam. A downstand beam is pretty normal because what that does, it allows you to take a piece of glass all the way to the floor. It also allows you to put a false ceiling in and hide all your services. The thing that doesn't look so great is, especially if you've got a desk and you've got a desk against a brick wall, is that you're going to end up with quite a thick aesthetic kind of band. Even there's quite thick. This will end up being something like 250, 320 plus this, which is another 400 plus. You end up with anything along something around 600 millimeters, 800 millimeters. And it's quite thick. So if you think about that aesthetic, if it was a curve, this gets quite thick. Or if it was an this won't be this gets quite thick. So if you want to reduce this, you can start looking at upstand beams. Because then, and if you pushed your column back, so it's interesting because this could end up being your structure as well, which is quite interesting, and you're reducing the amount of thickness that you've got at the bottom. The problem with that is you can't break that beam. So if you want to go from one space to the next space and the beam's in the way, your beam will have to be the perimeter for the whole space, whatever that case may be. So you can't have a beam running across and you go from one space to the next. Okay, I think that's enough for now around concrete structures and form aesthetics. Thank you.